Hello everyone, this is our major project on data mining with title Associative Classification over Data Stream, submitted by M. Nikita, P. Shruti, R. Divya and T. M. Soundarya under the guidance of Srimati K. Prasanna Lakshmi Ma'am, Associate Professor. Abstract. Based on association rules, associative classification has shown great promise over many other classification techniques on static data. However, the increasing prominence of data stream arising in a wide range of advanced applications has posed a new challenge for it. This paper describes and evaluates associative classification over data streams, a new associative classification algorithm for data streams which is based on the estimation mechanism of the lossy counting and landmark window model. We apply associative classification over data stream through mining several datasets obtained from the UCI machine learning repository, and the results shown that the algorithm is effective and efficient. The main aim of the project is to build a classification rule and predict the class label for the incoming data streams with the available or built classification rules. Modules present in the project are extraction of frequent item sets, building classifier, generation of classification rules, and prediction. The system requirements are hardware requirements and software requirements. Hardware requirements: Pentium 42.6 GHz Intel Core 2 Duo processor, a RAM of 512 MB, hard disk of 40 GB. Software requirements are operating system Windows 7, front-end frames and swings, frames using swings, back-end flat files. IDE NetBeans. In order to execute the project, the software needed is NetBeans IDE. So initially the NetBeans IDE must be opened, and then fim thread.java file must be executed. So we have to select the file and run the file. So the output of the .java file would something look like this. This is a frame which has initialization tab, FM over DS, frequent item set mining over data streams, and classifier tabs are available. So we have three buttons: load data set to streams, load description file, and initialization. So in the load data stream, we have to load the data set. Since we have to consider streams of data which represents a large set of data. For example, here we are considering mushroom data set. We have to open the mushroom data set. Mushroom data set is a huge data UCI repository with 8,127 records in it. And then we have to load the description file of that data set we have loaded. Then we have to fix the landmark size window. Landmark window represents the window with a fixed size. The incoming data is fixed for a window size, and then the frequent item sets would be mined for that particular sized window. And for the incoming data, the window size would grow with the given size, whatever size we have given, with accordingly the window will grow, and the frequent item sets would be mined for the new data along with the previous old data. So this is how the window would grow for the incoming streams of data, and the frequent item sets would be mined. So we have to select the landmark size window, and then we have to press the initialization. In initialization, the pre-processing of the data would be done, and then we get the initial timestamp and the completed timestamp. So this represents the window size, and this represents the starting of the time, the starting timestamp and the ending timestamp. So next we have to select frequent item set mining over data streams. So coverage. So coverage represents the support. Let us consider 11 as the minimum support. And then we have to select the initiate stream. If we select the initiate stream, the pre-processing would be done, and the frequent item sets for each and every landmark window for the incoming stream of data would be identified. The frequent item sets for the new data along with the old data in the window would be identified and shown. Since it is a large data set, it takes few seconds of time for execution. So let me show you how the mushroom data set looks like. So this is how the mushroom dataset looks like. The first column represents the class label of the data, and the other columns represent the attribute of the mushroom dataset. And next is mushroom description file. In the mushroom description file, we have classes like the first column in the mushroom dataset is E and T, which represents edible or poisonous, and all the attributes description would be shown in the description file. This description file would be used at the time of identifying the classification rules. To identify the frequent item sets in each and every window, we are using the a priori algorithm. So to find the frequent item sets, a priori algorithm uses the minimum support value and then identifies the frequent item sets. So the output would be displayed on the screen like this. So window 1 finalized with size 23 and variation found at record with ID 0. So the variation would be if we fix the window size, if we have fixed window size as 23. If at all the incoming stream has 23 records, then the window size would be satisfied. If at all the incoming data stream isn't 23 or it is less or more than 23, then the variation would be calculated and would be shown at the variation found at record with ID. And then the process of finding item sets completed. This represents that the a priori algorithm is executed at which level of the code, and then the total number of frequent item sets for each and every window would be displayed. And then we have to find the frequent item sets. So the frequent item sets for each and every window would be calculated and then would be displayed on the screen. The frequent item sets are also displayed on the screen. After finding the frequent item sets, we have to apply the association rule on the frequent item sets. We have to identify the associative rule. For that, we have to give the confidence value. Let us take 49 as the confidence value. We have to identify the classified rules. The classified rules gives the output of association rules. These are the associative rules identified. Then we have to get the output along with the class label. The input, since the input which we have given is in string format, the rules which we should obtain must also be present in the string format. So we press the button rules with label. This gives the classified rules. The classified rules are obtained from the association rules with the confidence value. So these represent the classified rules. And then we have to go for the prediction, which is the last module of the project. In order to do that, we have to load the test data. and then we have to press the predict button. So the prediction would be displayed on the screen. So the major part of the prediction is that if at all a new incoming data is arriving, the class label of that incoming data would be identified depending upon the classification rules we have built. So instead of checking for each and every attribute, the complete attribute would be considered at a time, and depending upon these classification rules, the prediction would be done. Since we are considering mushroom dataset, we have two class labels. Either it is poisonous or edible. So the data which we have entered, the classification rules are used and found out that the mushroom is whether edible or poisonous. Since it has to evaluate each and every classification rule, it takes some time. So the confidence, see, the test data which we have loaded, we have two data sets in the test data. So the first test data is shows that the mushroom is poison, and the confidence of that data set is 41.602, and the next data set which we have loaded represents the edible mushroom with the confidence 90.974. So these classification rules can be used for medical applications or pharmaceutical business company people. So if at all a cancer patient comes and he tells his symptoms, depending upon the classification rules built earlier, the patient, if he is having cancer or not, would be predicted with the prediction tab. So this is the advantage of associative classification over data streams. Thank you.